Alright there kiddos, here is your video for your review for your quiz tomorrow. I'm just going to work through the problems. If I go too fast for you, you can just pause and come back to it and pick up wherever you need to. But I don't want this to be a really long video. So number one, I have 2 times the square root of 32x squared y cubed, and I need to simplify this. Well, the 2 is already simplified, but what's inside the radical is not. Ignore the variables for a second and let's just simplify radical 32. So I need to break it down into its parts. Well, it becomes 16 times 2, so there's a prime. That becomes 4 times 4, and both of those make 2 times 2. So what I end up with are 2 pairs of 2's. And so I can take one of each of these 2's out of here. So I can pull a 2 from here and a 2 from here. So that makes 4. So I end up with 2 times 4 outside the radical. And then I have this 2 is a single, goes inside with the x squared y cubed. So 2 times 4 makes 8. And then I'm going to rewrite what's inside the radical as 2. And then x squared becomes x times x. And then y cubed becomes y times y times y, because that's what that means. This way I can see what I have that's a pair, a couple, and what I have that's a single. Well, I have a pair of x's, so I can take an x out to the front. And I have a pair of y's, so I can pull a y out to the front. And then my singles have to stay in. And so I have a 2 and a y remaining, and so this is what is simplified. Now number 2, you can't do anything with number 2 until the radicals look the same. I cannot add them as long as they're different. This 3 times the square root of 2x is simplified. I can't do anything else. But this square root of 8x, I can simplify. If I break down 8, it becomes 4 times 2, and there's your 2 times 2. So I have a pair of 2's, so I can take one of these out. So this stayed 3 square root of 2x plus. Now I can pull one of these 2's out. This 2 stays in along with the x that was already there. So now these match. They both say square root of 2x. So I can add them together. 3 plus 2 makes 5. And since they were both square root of 2x, then my answer is also square root of 2x. You don't really add the square root parts together. It's like saying I have 3 apples plus 2 apples gives me 5 apples. Or whatever you want to call that. But these become like terms. I just combine them. So now it's to the factoring completely, and we struggled with this on our last quiz, so it's good that you're going to see these again. Step number 1, look for a greatest common factor. If there is a GCF, you need to factor out the GCF first, then factor. If there's not, you can just factor away. So this first one, 2x squared plus 11x plus 12, there is not a GCF for 2, 11, and 12, so I can just start to factor. So I'm going to multiply 2x squared times 12, which gives me 24x squared. And then I have my 11x. So I need 2 numbers that multiply to make 24 that add to make 11. And so if I run through factors of 24, I get that 8x and 3x are going to be my 2 numbers. Now there are 2 ways to go about factoring this. There's the box method and there's the grouping method. They get you to the same place. I'm going to go ahead and do the grouping method, so that y'all can see that. So this becomes 2x squared, and instead of 11x, I'm going to write it as 8x plus 3x. And then I'm going to group. So I'm going to group these first 2 together and these second 2 together. And then I'm going to do GCF. So the greatest common factor for this first group here is going to be 2 and x, because they have that in common. If I take a 2x from 2x squared, it leaves me with an x. And if I take it from the 8x, it leaves me with a 4. Then my greatest common factor for these 2 is going to be 3, which leaves me with an x plus 4. Now these match, so that's good. So one of my factors is x plus 4. The other factor is the stuff that's not inside parentheses, the 2x plus 3. That is factored completely. You can't do anything else. Now, this is really C, because I'm going left to right. We'll come to the other 2 in just a second. Number 1, look for a GCF. 3x squared, 3x, and 6. There's a greatest common factor there. I can factor out a 3. If I factor a 3 out of each of these terms, I'm left with x squared plus x minus 2. Now I cannot just stop, because what is inside parentheses here can still be factored. And this is very simple to factor because you don't have a leading coefficient. It's just an x squared. It's not like this one over here that had a number in front. It's just x squared. So I need two numbers that multiply to make -2 that will add to make +1. And so if I do my math and I find my factors, it becomes -1 and +2. When I multiply, those make a -2. When I add, those make a +1. And so these become my two factors. So my factors become x minus 1 and x plus 2, and this 3 just has to follow along and hang out in the front. That is now factored completely. What happened on our last quiz where we had to factor completely, if you attempted to factor it at all, we got to this part and we stopped. You still have to see if what's in parentheses will factor. Now B and C here, the reason why I did them separate is because they are special. They're special cases. You see a minus sign in between a binomial. You have a binomial that's something minus something. You need to check it and ask yourself first, do these happen to be perfect squares? Because if they're perfect squares, then it's very easy to factor. Well, this is a perfect square. If I want to deal with this, 9x squared is the square root of that is going to be 3x, because 3x times 3x makes 3x squared. The square root of 16 happens to be 4. Now I'm calling them A and B, and it's because it's going to fit into a formula. Whenever you have this, it's called a difference of two squares, and y'all have been doing this all week whenever we've multiplied conjugates. It's the same thing. If you want to factor a squared minus a squared, it's just going to end up being, whoops, the conjugates times each other. So your factors will be conjugates. And every time we have gone and simplified something with a complex conjugate, that's what we've done. You've just done a squared minus b squared, and it came out to this. Well, now we're going backwards. I know a is 3x. I know b is 4. I got that from taking the square root. So my factors are 3x plus 4 and 3x minus 4. D here is something minus something, but they're not perfect squares. They are, however, perfect cubes. This says x cubed. It's to the third power. And if I use my calculator to check my cube root, remember you go to math, and then you go down to its number 4, and it looks like this. That's how you find the cube root. And so if I check these become cube roots, because a number times itself 3 times made each of these. So the cube root of 8x cubed is really 2x, because 2x times 2x times 2x becomes 8x cubed. And then the cube root of 27 is 3, because 3 times 3 times 3 makes 27. So there is a formula for this as well, and I'll make sure that I post this on the board tomorrow for your quiz, so you don't have to memorize it. But this is the formula for this particular problem. And so if I know what A and B are, and I got those by taking the cube root, I'm just going to plug them in. This becomes 2x minus 3. And then a squared is this whole thing squared, 2x squared. Well, 2 squared is 4. X squared is just x squared. Then a times b, 2x times 3 becomes 6x. And then b squared is going to be 9. So this is what it simplifies to. And if I were a really, really mean teacher, I would ask you to go ahead and factor this as well. But I'm not. If you stop here and we get to that, I'm going to be happy. So number 4 asks you to simplify some more square roots. So that's what we're going to do. So I have this radical plus this radical. Well, the square root of 6 over here doesn't simplify because its only factors are 3 and 2, and those are prime. So I don't have any pairs of anything, but this x to the 5th will. So I'm going to rewrite this as 6 times x times x times x times x times x. 5 times because it's x to the 5th. And then I'm going to see if I have any primes that are any pairs that I can get rid of. Well, these are a pair of x's, and these are a pair of x's, so I can pull one of each pair to the front. Well, I have an x times an x, which is an x squared, and the singles stay inside, so 6x stays under. Then I have to simplify this 24x cubed. Well, let's just break down our 24. It becomes 2 times 12, so there's a prime. 12 is 3 times 4, so there's a prime, and then 4 is 2 times 2. So I have a pair of 2's, so I know that I can pull out a 2 And then the singles get multiplied and stay under, so 2 times 3 is 6. And then that's x times x times x. Well, just like over on the other one, I have a pair, so I can pull out one of these. So it's really going to be 2x times the square root of 6x. Now my radicals match. I can add them up. So I can take this x squared and 2x and combine them, but I really can't because they're different. So I'm just going to write them as x squared plus 2x times square root of 6. This is the simplified version. Now we have to simplify completely some radicals. I'm going to rewrite this radical 56 over 2 as square root of 56 over the square root of 2. And because I have a radical in the denominator, to simplify it, I don't need a radical in the denominator, so I will multiply the numerator and denominator by radical 2. So 56 times 2 gives me the square root of 112. And when I multiply radical 2 times radical 2, it just makes 2. The radical disappears. Then I've got to simplify this 112. So I'm going to come down here. Hopefully I have space. And I'm going to simplify my 112. Well, I know that it was 56 times 2, so I'm going to start there. There's a prime. And then 56 breaks down into 14 times 4. Well, those are both not prime, but 14 becomes 7 times 2. We're good. And then 4 becomes 2 times 2. So I have a pair of 2's here, so I can take one of those out. And then this makes a pair of 2's. I can take one of those out. So 2 times 2 makes 4. And then the 7 stays under the radical. So I have 4 square roots of 7 over 2. But then I can simplify. 4 over 2 becomes 2 radical 7, and that is simplified. Now the square root of negative 12. I can't take the square root of negative 12, not until I pull out the imaginary part. So I'm going to have to take out the imaginary, so I have I radical 12, and then I'm going to break down 12. 3 times 4, which becomes, there's your 2 times 2. So I have a pair of 2's. Take out a 2 with the I, leave the single under the radical. So there is what that simplifies to. So last two, I apologize, these are not the last two. Two more. So number 7 here is two complex things being subtracted from each other, but there's an I in front of the second one I'm going to have to distribute. So this becomes 15 plus 3i. I can't do anything with it. I'm just going to drop the parentheses to help me. Then I have to do negative I times 12, so it becomes minus 12i. And then I have to do negative I times negative I, which makes positive I squared. Well, I can put these two i's in the middle together because they're the same. So I have 15 minus 9i, and then I squared is just negative 1. Well, now my numbers can go together. So 15 minus 1 is 14 plus 9i, and that is simplified down to the complex version. Number 8 is radicals with negatives. So I've got to take out the i's first. This becomes I radical 7 times I radical 14. I can multiply them together now. So I times I becomes I squared. 7 times 14 is 98. And I'm going to break down that 98. So 98 breaks down into, well, I just did 7 times 14 to get it. So there's a prime. This is 7 times 2. So there's another one. So I have a pair of 7s. So I'm going to pull a 7 out with my I squared. So I have 7 I squared, and the single 2 stays inside. But I squared is negative 1, so it's going to change the sign, and this is going to become negative 7 radical 2. So we'll simplify two more. 7 minus 2i divided by 2i. We got to simplify that. The 2i in the denominator, and I don't want to have an imaginary down there. It's not simplified if there is. And so I'm going to multiply both parts by 2i. You do not have to do negative 2i because this is not a complex number. It's just an imaginary number. Remember, it becomes complex when I add a real part to it. It's just an imaginary number, so there's no conjugate. It's just the number itself. So I have to multiply 2i times both pieces here. So I'm going to do 2i times 7, which is 14i. And then I'm going to do 2i times 2i, which becomes minus 4i squared. And then the denominator is also 4i squared. And I'll simplify. 14i. Now the I squared will change the sign of this 4, so it becomes plus 4. And this changes the sign of this, so it's negative 4. And so I'm done. I can't really divide, but every one of these numbers is divisible by 2. So I'm going to divide them all by 2 to get it to its simplest form possible. 14 divided by 2 is 7. 4 divided by 2 is 2. And negative 4 divided by 2 is negative 2. This is the simplified form. This one, however, number 10, has a complex number in the denominator. So to simplify that, this is where I multiply by the conjugate. So I have to do 5 plus 3i. So in the numerator, I have to multiply 4 times both pieces. So 4 times 5 makes 20. And then 4 times 3i makes 12i. And then down here in the denominator, this is where I have conjugate, so I'm just going to do a squared minus b squared. Well, a squared is 25. B squared is 9i squared. So the top stays 20 plus 12i. The denominator down here becomes 25, and the I squared here changes this to a plus 9. And so to simplify, I have 20 plus 12i over 34. And all of this is now divisible by 2. So I'm going to divide everything by 2 to get in simplest form. So 20 divided by 2 is 10. 12 divided by 2 is 6. And then 34 divided by 2 is 17. There is your simplest version. So that's the kind of stuff that will show up on your quiz tomorrow. Make sure that you study as much as possible. If you got something wrong, I will be here before school in the morning. You can come ask questions. Good luck. I will see you then. So here is your Easter egg, or your little hidden piece in your video. This is my dog Honey as she walked in the homecoming parade last week. For your bonus on your quiz, you're going to need to remember some things like what's her name, where were we, and it might even be important to know what she is wearing. I will see you guys tomorrow.